Hi. So, compilers basically transform source code to binary executables. And for most languages, the only way to run a project is to compile it first. Node.js applications, on the contrary, are executed using its source code. But there are cases where it would be useful to ship a single executable instead of source code and omit installing NPM dependencies and even Node.js. So today I'm speaking about PKG. Compiler may seem a too strong word for it. It is not that ahead of time compiler like Clang, but since it plays exactly the same role, let me call it compiler. It is available in open source at zay.co/pkg. PKG is a command line tool, and let's create a small application that outputs number 42. Oh, let's install it first. Oh, very sorry. I should use mirroring. Yeah. So I have just installed PKG. I've installed it globally, and let's make a small application. Look, there is nothing in this directory, and we make like So, node app.js will output 42. Let's compile it with PKG command line. PKG has its own customized version of Node.js. It is original Node.js we know with few patches that are open sourced. And now PKG pre-downloads pre-compiled binaries, and in order to make the executable quickly. So it is done, and we see that 3 more files are in the directory now, and app-macOS is among them. Let's look what is it. It is executable. Let's run it. It outputs 42. And now, what about removing original source? I deleted it and running it again. It outputs 42. So, let me switch to first, we created an application, simple application, and then we got 3 more executables created by PKG, app-macOS among them. And this is how the internal structure of that executable looks like. So at compilation time, PKG takes that Node.js binary. It takes source of application. It takes sources of its NPM dependencies. And it takes few seconds for PKG to output 1 or several executables. No need to deploy sources. No need to install NPM dependencies on Node.js. Only this particular binary can be shipped. And also, the project files are taken from inside that executable and not taken from their corresponding files spread over node-modules directory. And it causes slightly faster application startup. So let's use some NPM package, and for example, let's make a simple web server. So let's make a use of micro package that allows making microservices easily. Again, And such a one-liner like require this is just synchronous handler. Listen 8080. Okay, let's run it in node environment. And in a separate tab, curl locally 8080, outputs high. It works. Let's stop it. It does not work as expected. Great, let's compile it with PKG. Look, those binaries are not downloaded anymore. They are cached in local machine, in user's directory. Okay, app macOS. Curling it, it works. Stopping it, it does not work as expected. So let's even remove all the sources. Obviously, it does not work anymore. So let's run the application. Great, it works. So I've just shown that it takes NPM dependencies as well. Great. This is our updated structure of app-macOS internals. At compilation time, PKG takes all the files that are needed to run the application. And the list of those files and their content, their bodies, are called snapshot. Currently, snapshotted files are app.js and few files from micro package. And at runtime, when the executable is being run, those snapshotted files are available via so-called snapshot mount point. Let's check what is it and output a low-dir name. Okay. Oh, let's also output low-dash file name. And run it. Okay, let's compile it with PKG and run the compiled application. Look, these are paths in node environment, and these are paths in compiled state. So, at first glance, it may look like just snapshot path component was prepended to those paths, but not just that. When the executable is run, from the viewpoint of JavaScript code inside that executable, all project files that were taken at compilation time, snapshotted files, reside inside virtual snapshot subdirectory of root. But aside that snapshot path component, their paths remain the same as they were at compilation time. So you can really think of a snapshot as a mount point to some internal virtual read-only file system that contains initial files of the project. This is our ever-changing structure of app-macOS. Also, please note that all that is outside that snapshot subdirectory, snapshot virtual mount point, is real file system we know. But developers don't need to deal with that snapshot component manually, despite, as you see, it is exposed to low-dash file name and low-dash dir name. There are no reasons to check its presence in any path, nor to strip it. because that snapshot is for PKG internals only. What are those internals? During the runtime of application, PKG installs a hook over native Node.js FS file system API module, and it is the hook who checks the presence of snapshot path component in all paths that are passed to FX functions. So if it is present, the file requested, its body is served from inside executable, from that payload inside. Otherwise, the code is just passed to original FS function. So what happens when require micro is called inside compiled application? As you have just seen, low-dash dir name contains snapshot path component. And also may I remind you that require resolves given argument against low-dash dir name of the file it was called from. Hence, require micro is tricked by that hook to look for micro package inside executable again, inside that snapshot mount point. This means that for most cases, PKG forces require calls to work with the snapshot only. In other words, with the executable only. And this is the main reason why the executable is standalone and self-sufficient, disregarding of the number of files in Node low-dash modules. I mean, at the compilation time, say. So, you see that such mount point approach preserves the way how require and other path-related logic works inside compiled application. And in most cases, it does not need any action from developer to make application work correctly with PKG and particularly with PKG path tricks. Okay, that was all about placing JavaScript files into executable. And what about non-JavaScript files like HTML, CSS, images? It would be useful to place all that assets into executable along with web server logic to make it even more portable, to avoid deploying assets as separate files along with executable. So that non-JavaScript logic is covered by the same snapshot functionality. You just need to use low-dash dir name for your path construction. For example, here low-dash dir name is used to construct the path of usage.txt, and usage.txt variable gets snapshot path component as well, and hook inside read file sync captures it and serves the body of usage.txt from inside the executable body. Okay, that was all about placing files inside the executable. And what about real file system, how to access files outside executable? Despite all the project files now reside inside the executable, there are still path values that make sense even in that case. Process.cwd, current working directory, works the same way. Process.execpath points to the Node.js binary executable when it is run in Node environment, but here it points to, obviously, the executable, the compiled executable. IRGV0 is the same for recent versions. And IRGV1, when it is executed in Node environment, it points to full path name of main entry point. And for compiled application, it points to the full name of mount of entry point as well, but with prepended snapshot component. For example, if you want to use some configuration file to be editable, that is placed inside to the same directory as the executable, you can use execpath. You see, execpath does not have a snapshot path component, and the hook inside the read file sync will take no action. So this is the structure. Please note that app.yaml is outside of executable. It is on real file system. And one more useful feature, for example, if you want to place almost all the logic of your application to executable and leave something outside as a plugin, for example, you just need to require that JavaScript file, but be sure not to take --dirime, for example, or just use any of these path values in order to deal with the real file system. So, but there are still some cases when we need to distinguish when the application needs to know if it is run inside executable or if it is still in node environment, to preserve both ways to run it. Yeah. So you can use process.pkg. PKG at the runtime of application populates this entry. If it is present, the application is run inside executable. So finally, in order to make an application work with PKG correctly, you will probably need to make few changes, mostly path related. But it is very important that it is not a one-way ticket. You can preserve, PKG preserves the way, the ability to run the application under node. So far, I have talked about placing JavaScript files inside executable as is with sources. And however, PKG has an option to place machine code instead of sources into executable. This is how require call simplistically works. This call chain transforms file.js into its content, its body, into so-called wrapper function. It is called, the function is called immediately. It populates module.exports value that is used as require call return value, require call result. And look at new script. Despite it is used internally in require, it is available as API in VM API module, and it is documented. Let's look at its documentation. It has options object, and look at cache data. A new script can produce cache data and can consume it. Originally, cache data was implemented to speed up loading of JavaScript files of your choice, to bypass parsing its content, and to make use of machine code. But at compilation time, PKG uses it for its own purposes. At compilation time, PKG produces cache data. Cache data is machine code. And PKG stores cache data inside executable instead of source code. So its advantage is that source code is not disclosed at all. But it has a drawback. But before talking about drawback, let me show what what cache data is. This is V8 compilation pipeline, and with full CodeGen and crankshaft. Full CodeGen takes source code and produces unoptimized machine code. Cache data is that unoptimized machine code. Then that machine code is run, type information is collected, and then crankshaft takes type information and JavaScript source code in order to make optimized machine code and run full speed. But obviously, if we, in that sourceless mode, do not provide JavaScript source, and if we provide only cache data, we cannot get that code run full speed. And this is that drawback I told about. So we expect this drawback be fixed in future. The fact is Node.js will eventually switch to V8 version with compilation pipeline based on ignition, bytecode generator and interpreter, and turbofan optimizing compiler. Look, turbofan does not need JavaScript source code in order to make optimized machine code. So our expectations are that cache data that PKG places into executable will contain bytecode sufficient for turbofan to create optimized machine code, thus preserving the state that the source code is not shipped. Okay, there is one more reason why PKG will benefit from ignition. You may have already noticed that along with app-macOS, PKG produces two more binaries, app-linux and app-win.exe. They will obviously not run on this machine right away, but they will definitely run on their corresponding platforms. So PKG supports cross-compilation, but with a limitation. It is cross-platform compilation and not cross-CPU. This means currently if you have an x64 machine, then you can create executables only for 64 machines, disregarding of the operating system. So you cannot make for IRM, for example. This is because V8 in compiled state obviously does not need other code gens, code generators, machine code generators, except for the current host machine. No need in them. And it would be a significant effort to make it include several code gens and to accept an argument to choose one, for example. So no need to do it, and especially in the view of new pipeline coming soon. And our expectations are that cache data from the executable will eventually contain only CPU-independent bytecode, thus removing CPU limitation of PKG cross-compilation. Thank you very much. So, questions, please, if you have. Please.
So when you said snapshot, you weren't talking about like V8 heap snapshots, right? Like it was just your file system snapshot. Like you're only capturing the code gen code, not like MK snapshot, like a snapshot generator.
No.
This would make sense. I'm just like asking what.
You mean heap snapshot, V8's functionality of heap snapshot. It has particularly two ways to make use of machine code. It is called a heap snapshot that makes the total snapshot of some state, and in such a way that you can provide it in the whole upon next startup, and thus speeding up its startup. And there is another way that is used in PKG. PKG makes machine code for each particular JavaScript file. If you look into that cache data functionality source code, you will understand that it is per file functionality, not the whole heap snapshot. That is why it is used, because for example, currently you can specify that only your code, of your project, need to be shipped as cache data, as machine code, in order to hide, particularly hide is a bad word, not hiding, not hiding, but just not shipping at all. Not ship your particular object, but it is fine to ship the source of packages in Node Lodash modules. Obviously, they are open source, and no matter if someone extracts their sources from your application, from your executable. So, in order to implement such functionality, to choose which files we need to machine code or we need to JavaScript, we had to use not V8 snapshot that is a whole, but we need to use per file generating of machine code of cache data or placing JavaScript code to make it run full speed. Because just imagine you may just pipe your code, just imagine it only pipes the stream. Yeah? So it does almost nothing, and it is not that bad that it works as unoptimized code. Because all other packages that you use, and they are part of that stream pipeline, that are still open source, and thus they are placed as sources, and they are on full speed. So this is not that significant speed slowdown as you might think. It is the project is open source now, and you can clone it. Please go to z.co/pkg. Any more questions?
What's the base image size?
What's the base size of, like, with your console.log 42? Is that like around 30 megs or?
Its only disadvantage is that the executable is itself particularly Node.js binary.
Right.
And it will be at least the size of Node binary, plus that payload. I did not make measurements, but it is not that big.
Okay. Cool, thank you.
Hi, first thank you for this project. It's pretty awesome. I have a question about, for example, I'm using Sentry for catching the errors on production. And what about the source map on the binary?
Indeed, the source map is available only if you, full source map, only if you ship as source code. But currently, even with full code gen and crankshaft, there are still stack traces, and there are except line numbers. So you get function names, and you get the files they reside in. Unfortunately, line numbers are currently not shown yet. It is a vector of future work. We know the issue, we know how to fix it, and it will be fixed soon. Thanks. Feel free to open issues. Feel free to contact the way GitHub works. And if you did not ask questions right now, please feel free to contact us. Thank you.